Okay, so now we're going to talk about documentation, and this will just be real quick. We're going to talk about the different components that you need for an assembly drawing or any drawing in general. We're going to define what a parts list is. We're going to define what a title block is. We talked about these things when we went over the puzzle cube, but judging from the test, some of you may not have put a name with those specific components. So documentation. Once a design has been approved and fully researched, the parts need to be prototyped or manufactured. To do so, we need to have appropriate documentation to communicate the idea to everyone in the company. Documentation is the most difficult, time-consuming, yet most important part of an engineering communication. This documentation is done with working drawings. Working drawings. Working drawings are a complete set of drawings that document how an object will be manufactured and assembled. Each set should include part drawings, assembly drawings, part lists, specifications, or instructions. So part drawings. A part drawing is a drawing that contains all the information for making one part of the design. This drawing consists of dimensioned orthographic views. If necessary, you'll have a section, auxiliary, detail, and an isometric view can help document the part. All features of the part will be dimensioned so that it can be manufactured. So this is a part drawing. Notice it's just one part. We've dimensioned it fully. You did this with each one of your puzzle pieces. Title blocks. So we're going to talk about title blocks. Title blocks are necessary to identify the drawing, the general details that go along with that part, and an example showing the parts of the title block are shown on the next slide. So this is a title block. Yours is just real small down at the bottom. It'll have a title. So this example is ANSI, large style title block. Title blocks can be customized by a company but may contain the following information. One, you're going to need the person's name who created the drawing. Name of person who checked the drawing. Just like first drafts of paper written in English, drawings go through many revisions. The drawing may be checked for quality assurance to be sure that it meets all the company's standards and requirements. Remember, working drawings are made of many different types of drawings. More than one sheet usually goes with the design. So this is showing 1 of 4. Scale of the part is important so that the reader understands the relative size of the parts. Title of the project as opposed to a specific part. Drawing number or specific part name in a relationship to the total design. Zoning is used to find specific locations on the drawing, usually shown in numbers or letters. Another person will check the drawing and approve the part for manufacture. And then documentation of how many times drawing has been changed. And then this is the size of the sheet. Important when reading a drawing to ensure the drawing is printed to display the proper scale accurately. Also valuable when printing. And then any general notes and information located here you'll see like the tolerances and general information that would take up too much space on the drawing if repeated on every feature. So here we have just all fillets and rounds are 0.12 or 0.125. Okay, so assembly drawings show how parts of a multi-component design fit together. Generally depict at least one orthographic projection. Full section views often used to show necessary internal features. So, if we have a part that needs a section view, we will put that in the assembly drawings. Shows how most of the multi-components fit together and generally depicts at least one orthographic projection. So here we have our front view. It's split in half, and it's showing how the parts fit together. We have our balloons here. Assembly drawings may contain one or more views, including sections or auxiliaries, enlarged views of small details, overall or specific dimensions for assembly, notes on manufacturing processes, balloons to indicate item numbers, and parts list or bill of materials. So, assembly drawings always have these balloons and parts lists, or may contain them. Design assembly, general assembly, detail assembly, erection assembly, subassemblies, pictorial assemblies. We're going to talk about those. Design assemblies. Assemblies show relationship between components. Here we have the design assemblies often used on preliminary design processes, sketches before the product is modeled. General assembly. Most common type of assembly drawing is a general assembly, displayed as multi-view drawings, sometimes with a section view. General assemblies are not dimensioned. A detail assembly combines an assembly view with several parts as dimensioned. Multi-view drawings on one, and dimensioned multi-view drawings on one drawing sheet. It reduces the number of drawing sheets, more appropriate for designs with small number components. So here's an example of a detail assembly. An erection assembly, similar to general assemblies, except dimensions and fabrication specification are commonly included. Typically associated with cabinetry or products made from structural steel used for fabrication and assembly. And then sub-assemblies are complex or large assemblies often communicated through sub-assemblies, which are just smaller assemblies. So we take a huge assembly and we break it down into smaller assemblies, like we were talking about yesterday, where we could have broken down the train into the wheels. Pictorial assembly, usually isometric or perspective drawing, may be rendered to imitate photographic quality. So we use these with sales productions, self-assembly, maintenance procedures. Pictorial assemblies often used in catalogs, journal articles, and advertisement. This pictorial is sectioned to show interior details. Exploded pictorial assembly. Drawings commonly show how individual components fit together. And this is what you guys will be doing. They have balloons, and these are our balloons, is a circle with a single number connected to the assembly component with a leader line. Balloons on drawings are always the same size. They're grouped in an easy-to-read pattern. Balloon numbers correspond to item number and parts list, and Inventor will do that for you automatically. Balloons do not have horizontal or vertical leader lines, so you want those to be diagonal. You want the leader lines to be diagonal. Parts list is a table with information about each part contained in an assembly. Item number corresponds with balloon numbers. So this is a parts list. A lot of you guys missed this question on your test. It just tells you how many you have in an assembly and the name of the part, and sometimes there's descriptions. So for like a screw, you would add in your threads. Part list information. Items typically on parts list, item number from balloons, quantity of a particular part needed for assembly, parts or drawing numbers as reference to the detailed drawing, descriptions, material identification of part, information about vendors. So again, and sometimes we list the materials on there, and then we have items numbers, so this is what corresponds with our balloons, and then how many there are actually in the assembly. Parts list location. Location of parts list specified by company standard. Common locations include above the title block in the upper right hand corner, upper left hand corner, convenient location on drawing. So really, it's your company. They'll set that standard where they want the parts list if you join an engineering firm. Here's a common place for it. I place mine up at the top. Either is fine. Okay, so what I really want you guys to take away from this is balloons are always vertical, or I'm sorry, are always diagonal. They're never straight vertical or horizontal. This is a parts list. This is a title block. These are balloons. And this is an exploded view, what you guys are about to do with your train. Okay, so I'm going to exit out of this. Bring this up. So there's my exploded view, and I would prefer that yours go in this direction. On this axis, mine went in this direction. I don't have a mouse with me at home. I just have my laptop, so it's a bit harder. So I'm going to open up a drawing file. Skip. So here we go. We bring it up. We bring in our base, which is going to be my train, my IPN, and I'm going to want to scale that down. So I'm probably going to go to Edit View, and I don't want a 1:1 scale. I think probably 3:1 might be best. No, that made it bigger. What am I doing? 1/4. There we go. That looks better. And if you don't like, and I don't like this view, so like before, you guys can always edit view. We'll delete this. And then I'll create another one. One, 4. Okay. And you just want to kind of pick which one best represents. And with mine, it's like none of them. So I cannot. I guess that one might be the best. I'll delete this one. Okay, then you want to go up to Annotate. You want to put in a parts list, which is going to list all your parts. And just put in that IPM file. We'll see if this works. Add some. Okay. And then you want to come up here and add in balloons. And remember to place those vertically. And you should see number 7. Or I'm sorry, not vertically, diagonal. I don't know why. You know, the smokestacks right there. I see, honey. Hold on.